Now let's take a look at example 4.4. A ball is projected vertically upwards from a point A with an initial velocity of 60 meters per second. So this example is about vertical linear motion. The question asks us to find to what height will it rise? How much time will it take from the instant of projection for the ball to reach a height of 30 meters above A on its return journey? And finally, what will be its velocity then, which is at point C? So let's visualize this example. We have a ball. It is thrown from point A with an initial velocity of 60 meters per second. Obviously, the ball will rise up against gravity to a certain point H that the velocity turns to 0. So this we consider that as a first stage of motion. And from the lecture, we understood that when a body travels against gravity, A is taken as negative 9.81. So for the next stage, the ball will accelerate downwards due to gravity. And for that, we learned that A this round is taken as positive 9.81. And for that, we consider that as the stage 2 of the motion. So let's start to solve part A. To what height will the ball rise? Well, this is stage 1 motion. Let's focus on that. So let us ask ourselves, what information are we given from the question? Obviously, we have the initial velocity of 60 meters per second. The ball will displace to a displacement of s and rises to a point where the final velocity will be 0. So let's pen all this thing down. These are the information given by the question. So our objective is to find displacement s. That means the height that the ball rises from point A to B. So looking through the kinematics formulas that we are given, there's one formula that stands out, which is V1 squared equals to V0 squared plus 2AS. Why should we use this formula? The reason is very simple, because the given values are contained in this equation and the unknown, which we are trying to find, also reside in this equation. So by rearranging what we need to find, which is S, we have this simple formula with the values all given in the question. Plug them in and we have the answer. The height that the ball rises will be 183.49 meters. Next, part B asks us to find how much time will it take from the instant of projection for the ball to reach a height of 30 meters above A on its return journey. So the question is basically asking us to find the time taken from point A to B and from B to C. So we have to solve the time taken for both stages of motion. So let's focus on stage 1 first, A to B. So again, pen down all the information that we have for this stage of motion. And obviously, in order to find time, the acceleration formula is the one we should be employing. So by rearranging the equation and plugging in all the known values, we will have the time t1, which is 6.12 seconds. That's what the time was taken for the ball to travel from point A to B. So for the stage 2 motion, which is the downwards motion, let's focus on the motion itself. So we know that for this stage 2 motion, the initial velocity is 0 meters per second. And the final, do we know the value? We do not know at this juncture. So let's pen it down. Stage 2B to C, along gravity, what are the known values that we are given? Well, V1, unknown, never mind, we just put V. V0, 0 meters per second. Acceleration, obviously, positive 9.81. Now, can we use the V1 square equals to V0 square plus 2AS formula as what we employed previously? We can't, simply because we do not have the V1 values. But from the part A, we know that the total displacement from point A to B is 183.49 meters. So now point C is 30 meters above point A. We can actually compute the displacement from point B to C. And now we can use this kinematics formula, S equals to V0 T plus half AT square, simply because it contains the unknown that we are trying to find, which is time T, and the rest of the parameters in this formula, we have them as V0 and A. So rearranging them, substituting the values, we will be able to acquire T2, which is 5.59 seconds. So we need to find the total time taken from point A, B to C. And point A to B, we have just gotten, it's 6.12. Sum them up, and we have the answer for part B. So for part C, what will be the velocity at point C? Now again, this is the second stage of motion. Stage 2, B to C along gravity, pen down all the information that are given. Now we are trying to find the final velocity V1, which we put it as V. Now a simple utilization of the acceleration formula, we will be able to find V1. And therefore, V1 is equals to 54.84 meter per second.